Hello everyone, welcome back to TezAsia 3.0 powered by Tezos India. So in this session, welcome to the fourth session of the workshop series of TezAsia 3.0. And today we have Tarun Sharma, SDE at Tezos India, who will be teaching us about how to connect front end of the dApps on Tezos using Taquito.js. Why we need front end? Because as far as we know exactly and how we do things, it is necessity that major people don't know about the code basics. Although we built smart contract yesterday, we were aware that there is a platform known as the Better Call Dev and TZKT, where you can actually check the entry points and interact with the smart contracts on chain. But a normal user can't use it and doesn't know how to interact with the smart contract, because at the end, if we use a platform, if we use a service, we only interact with the front end part, the UI part, where we enter the field, we click on things and get our things done. So for that, I am welcoming Tarun Sharma, SD at Tezos India. Hi Tarun, how are you?
Hello, Simar. How are you? I'm good.
I'm good. What about you? Enjoying the
I'm doing
Sunday?
great. Yeah.
Okay. So the stage is yours. Please share about how we will be connecting the front end of the tabs on Tezos using the Taquito.js, and the stage is over to you.
Okay, sure. Uh, Let me know if my screen is visible.
Yes, your screen is visible now.
Okay, so hello everyone. I am Tarun. I'm SDE at Tezos India. I've been building on Tezos from past 2 years, and I'm also co-founder of TestStyle, which is a Web3 based game. So today we will be learning how to connect our front end from the smart contract using Taquito.js. So there are few prerequisites for this workshop today. I am sure you are all aware of SmartPy as you have attended the past few lectures and the workshop conducted yesterday by Sanket. So today we will be implementing that smart contract in our front end using React. So what we will learn today? We will learn what is Taquito, how does Taquito work, and how can we use Taquito in our own project. And later we will start building our front end of the lottery smart contract which we created yesterday, and we'll connect it to a DApp. So what is Taquito? Taquito is basically a JavaScript library which is used to read all the data from the Tezos blockchain. We can read all the smart contracts, all the storage of smart contract, as well as interact with it. We can send transaction to the smart contract as well as direct to the blockchain node. So there are various tools which built on Taquito, and all it's the one of the best framework present around to interact with the Tezos blockchain. So when we connect to a contract, how does that work in a top level view? So whenever we can inject a transaction to a blockchain, what we does is we connect to a single node of the blockchain. And whenever we push our transaction to that particular node, it floods the entire blockchain network with the transaction object. So in order to connect to that single node, we refer to an RPC URL. That's basically the address of that node. So for today's workshop, we'll be using GhostNet RPC to connect to our Tezos node. GhostNet is a public test net which is used for building and testing purpose on Tezos. And in order to interact with this public Tezos node, we will be using Taquito to make a bridge between our smart contract and our front end app. So you must be wondering that we can already interact with our smart contract using Better Call Dev or let's say TZKT. So why do we need Taquito? So yes, we can interact with the blockchain without using Taquito as well, but it will be a very complex process. So first of all, we need to build an object which will have several parameters which we need to pass to the blockchain. So they will have, you must be familiar with all of these parameters, but there's a special Michelson object which is pretty tough to compile, as all the smart pi code compiles down to Michelson, and we have to break down our code to Michelson in order to pass it to the Tezos blockchain. So we need to build a Michelson expression in order to create a transaction object.
Tarun, I'm audible.
One,
Yes.
yes, Simmer, you're
You,
audible.
can you do the can you share the full screen? I think it's not visible correctly. Your slides are not visible. So in case you can do the full screen mode, it will be better as of now.
Sure. Is it visible now?
Yes, it's visible now. Thank you so much.
Okay, Simmer. So I will continue. So even without Taquito, we can sign our transaction by creating an object of transaction. So all these parameters can be built easily, except this parameter part, which is a Michelson compiled object. So every expression in the smart pi breaks down, compiles down to a Michelson code. So in order to construct this parameter field, it will be a quite a complex challenge. And even after compiling this whole object, we need to convert it into a signed byte and then post the operation manually to the RPC URL. So without Taquito, we need to do a lot of tasks to just post a simple transaction to the blockchain. And with Taquito, it's just the as simple as like writing a single line of code. So if you are coming from Solidity or Web3.js library, you must be familiar with the contract instance. So it is very similar in Taquito as well. We just need to create a contract instance, and then we can call out any method of that contract. So let's say we have a method named add items. So we can call contract dot method dot parameter name and pass all the required parameters directly, and then do dot send to just send the transaction. So it is very Web3 way of doing a transaction using Taquito. So how do we set up Taquito in our current working repository? So in order to install Taquito, we just need to do npm install @taquito/taquito, or we can download it directly from the package from this link. But it will be simple if we use npm install Taquito. And once Taquito is installed in our node modules, then we can just import the Tezos toolkit from Taquito and set up our Tezos instance by passing the RPC URL of the node which we want to connect in Taquito. So these are few common interactions that we can do using Taquito. So in order to read the data from smart contract, what we can do is first we need to create a contract instance by just passing the contract address to the wallet method, and then we can fetch the storage of the contract, or we can fetch any of the storage variable or a big map from the contract in the following ways. We will be talking about it late when we build the dApp. And in order to send the transaction to the smart contract, what we can do is, again, we need to initialize the contract instance first, and then from the methods we can select the entry point which we want to call, and we can send the parameters directly to that method by a single line of code. And then we can wait for the operation hash and the operation confirmation by op.confirmation method. So what are we making today? So in the previous workshop with Sanket, we have built a lottery smart contract. So today we will create a front end for the same lottery contract, and I have created a boilerplate for you, for which you can just clone and follow along with the code. So we will be having a simple nav bar with a connect button and a button to buy tickets and end game. So we will be using React as well as TypeScript to follow the today's tutorial. We will be using Temple Wallet to connect our wallet from the front end, and we will be using GhostNet as our RPC URL. So this is the contract which we deployed in our last workshop. If we go to Better Call Dev, we can just check that we have few previous transaction happened in the same contract, and this is the GitHub URL for the boilerplate which I created for you. You can just go to the URL and clone the GitHub repository so we can start the tutorial. I will share the boilerplate link with you on comments as well. Simar, can you share the link in the comment?
Please share it in the chat section. I will share the link in the comment section also.
Yeah, sure. So once you go to the GitHub repo, you will see a boilerplate code. You can just clone the code using the HTTPS URL or using GitHub desktop. Once you have cloned the repo, you will see you can open it in your code editor. So we will be using VS Code Editor for today's workshop. So once you have cloned the repo, just type npm install, and it will install all the dependencies which are required for the workshop.
Tarun, can
So
you share the link
uh,
in the chat?
yeah, I am not connected to YouTube.
No, 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 in the private chat. In the private chat.
Okay.
Yes.
Fine. So if you are using your own project, you just need to install the Taquito library as well as the Axios library. I think it's not imported here by default.
Please zoom in on the code. It's not visible as of now.
Okay. Is it visible now?
Can you do a little bit more? Yeah, it's visible now.
Okay, so we just need to have the Taquito library in order to start the development, as well as we are using White as our interpreter instead of React script because it supports Webpack 4 as of now, and Webpack 5 is not supported by the Taquito library. So just clone the boilerplate and do npm install. It will install all the required packages. Uh, just a second. Yeah. So our first step will be to setting up the Tezos toolkit. For that, we can do import Tezos toolkit from Taquito library, and then we just need to create a Tezos instance. By convention, we name it Tezos with small t. So we will just set up a new Tezos toolkit, and we need to pass the RPC URL which we will be using. So for our smart contract, we are using GhostNet. So this is the RPC URL of public RPC URL of GhostNet. So we will be using this, and that's it. So we have set it up our Tezos toolkit, and we can export this because we will be using the same toolkit in our app throughout. So once this is done, then we need to move forward and set up our Beacon wallet instance. So Beacon wallet is basically a aggregated wallet for Tezos. So if you go to any Tezos that, let's say, people swap, so what Beacon wallet does is it aggregates all the wallets which are there in the Tezos ecosystem, and we can connect it through a single pop-up. So we can connect to any of the available Tezos wallets. So in order to set up this, we need to have a beacon wallet instance. So to do that, first we will do import beacon wallet from Taquito beacon wallet, and then we need to create a wallet instance. So for that, we will do const wallet beacon wallet instance, and here we need to pass an object with name. This name is the name of our application. So let's say this Tezos lottery and preferred network. This is the network which we want our wallet to be connected to. So as we are using TypeScript, we need to import the network types as well. So network type from air gap. And here we can do is network type dot ghostnet. Okay, so it is type one. So we are connecting to the ghostnet network from our network types of beacon dApp. So this is the wallet instance that we'll be using. Let's export this as well, as we'll be using the same wallet instance later. So whenever we click on our wallet button, it requests us to connect to any of the desired wallet that we want. So in order to have this similar functionality, what I have created is a connect wallet function and a get account function. So whenever we connect, first we need to ask for permission, like which wallet we have to connect, and once we connect to a wallet, it will ask me to connect me to a separate account which is there in the wallet. So once I connect to an account, the account will be fetched by the button here. So for these two operations, I have created two separate functions. First is the connect wallet, second is the get account. So in the connect wallet function, all we have to do is we need to just await for our wallet instance to get connected to a wallet. So we have to do wallet dot request permissions, and here again we need to pass the network that we want our wallet to be connected to. So in the network type, we just pass the type, and it will be network type dot ghostnet. So whenever we call this connect wallet function, it will initiate the beacon wallet to request permission from a specific wallet which user want to connect from the ghostnet net. And in the get account function, we have to fetch the connected account which user have connected through their wallet. So what we need to do here is const connected wallet, and we have to await for the wallet to get connected. So we'll do wallet dot client dot get active account. So this will be the account which user will be connected to, and there can be condition that user might not have connected after initiating the permission. So we have to check whether it's an empty connection or not. So for that we will do if connected wallet, then we will return the address of the wallet, else we can return a empty string. hide the console here. So in this way, our wallet connecting functions are complete. So now we need to connect our wallet instance to our Tezos instance so that our Tezos toolkit knows from where are we connecting to the wallet. So we just need to set the provider for our Tezos toolkit. So for that we can do Tezos dot set wallet provider and pass the wallet instance here. So it get auto imported from our wallet file. So this is basically the initial setup which we need to do in order to connect our wallet from the Tezos toolkit, and we can use this wallet functions to get called whenever we click on our component. So let's just start our app. So to run our app, just do npm run dev. It will run our app on localhost. So this is the basic boilerplate UI which I have created from Bootstrap library. So we have a connect wallet button on the top, a buy ticket button on the center, and a ticket remaining count, which is buy now set statically using a state. So what we need here is whenever you user click on this connect wallet button, it should have something similar to the sweep to swap. So it should pop up the beacon wallet instance, and our wallet should get connected, and our wallet address should be visible somewhere here. So to do that, let's go to the neighbor component, and first let's complete the call for our wallet connection. So what I need to do here is await for the permission which our wallet is requesting. So for that we can do the connect wallet function call. So on connect wallet we need to await for connect wallet first, and this will do the pop-up get the pop-up initiated in our front end. So once the user calls the on connect wallet function, the connect wallet function will be called and there will be a pop-up. Now once the user connects a wallet, we need to fetch that wallet and set it in the account state. So we can have that account showed in our button as well. So for that, what we will do is we will create another we will call the get active account function. So for that, I need to pass account equal delete and get active account. So once we get an account, then we just need to set it to the state which I've already created. So set the create account. So, so whenever someone calls the on connect wallet function, it will first call the connect wallet function, and if the user connects to the wallet, then we can fetch the account and set it to our local state. So here as you can see, here is the button of the connect wallet. So I will just do an on click call here on connect wallet function. And here we can have an if else state. So if our wallet is connected, so there will be account. Then we can show account address. Else we can show a connect wallet. But so for that, what we will do here is so if we have our account connected, then we will show the account address. Else we will show a message that is connect wallet. So let's save it and restart our server. Now when I click on connect wallet button, there's a beacon wallet pop-up, and if I connect to temple wallet let's so once I connect to my wallet, uh, we see the wallet address here instead of the connect wallet button. But what happens now is if I refresh my page, the connection will be lost. Though our app is connected in the backend from the wallet, we are not fetching the active account whenever the pages get refreshed. So if I click on connect wallet again, it will ask me again to connect my wallet, but as our app is already connected, we can just fetch the active account here as well. So for that, we can use a use effect and set the account to the connected account already. So for here, we can again just do a get account call. So await get account, and if we get an account connected, then we can set it to the account address. So now when I refresh a page, the connection remains intact. And if I want to switch my account, I can just re-click on the connect button, and now the account got switched to the second account. And now this account is the active account which is connected. So before I move to the other part, is there any questions till now? No questions so far.
No, as of
So
now, we
let's
don't
move
have any.
to the next part. Yeah, let's move to the next part then. So once our wallet is connected, now we have this ticket remaining call as well as this buy ticket button. So next we will move to the buy ticket operation. So to in order to interact with the smart contracts buy ticket entry points, first we need to have a contract instance. So this will be done similarly to what how do we interact it directly from the better called apps. So here we have a buy ticket operation and we do not need to pass any parameters. Just execute this call. So this will be done using the contract instance of Taquito, which we have studied here. So we just need to create a contract instance and then call the entry point method, which we want to call from the contract, and just do a send operation. So in the utils folder, there's an operations.tsx file. And here I've already defined the operation. So what we need to do here is uh, create a contract instance from our Tezos toolkit first, and then call the method which we want to execute. So for that, first we need to create a contract instance. So let's create a contract instance, and we will need our Tezos toolkit instance here. So as we have exported it already from here, we can just import our Tezos toolkit here by typing Tezos, and it will get auto imported. So we need to go to tezos.wallet.at, and now we need to pass our contract address. So this is the contract which we have created in our last workshop. We can just pass the contract here, and that's our contract instance is set it up. Now we just need to pass the operation. So like I mentioned, it is termed as OP for operation, and we just need to do contract dot methods, and we need to call the buy ticket operation. So let's say buy ticket. We do not need to pass any parameter to the buy ticket operation, so we will leave this empty, and now we will do a send. So if you remember, when we call the buy ticket entry point, we need to spend one test as well in order to buy a ticket. So in order to define that, we can define it here inside the send call, and we can specify the amount we want to send. So let's say it's one, and to specify it's one test and not mu test, we have to set the mu test to false. So we are sending amount one test here. So if we want the amount to be in mu test, we can set mu test to true and pass 10 to the power 6 here. So to not make it complex, let's just pass one test here and set mu test to false. And once this operation get confirmed from the blockchain, we will be certain that our transaction is passed. So for that, let's do an await operation and wait for operation to get confirmed. This is the number of confirmation we want before proceeding further. And in order to make it a bit intact, let's wrap this up in a try catch block. And in case there is error, we will just throw the error. So here in just 3 lines of code, we have successfully interacted with an entry point of our contract. If we were have to use a non-Taquito based approach, so we have to build our own parameters here for sending the muters, and then we have to call it again specifically by posting the object to the RPC well. But Taquito has saved us a lot of time by just making this function intact in the Web3. So once our function is created, let's just call this function. So in our app.tsx file, uh, I have created this on buy ticket function. So whenever a user click on the buy ticket button, we will call the on buy ticket function, and here we can just await for the buy ticket call. So we can do await buy ticket operation. When I write buy ticket operation, it gets auto imported from our operations. So what most of the users do is leave the code here only, and this will for sure work. So whenever I click on the buy ticket, let's just initiate the call here as well. Click on buy ticket. So now if I click on the buy ticket, there will be a temple pop up, and I will be redirected to send one test to the buy ticket entry point. So I can see the transaction here is getting built, but in the front end of that, there is no communication whether I clicked on the button or whether the transaction is being sent or not. So if I just buy a ticket here, the transaction will get confirmed by the blockchain, but there is no communication from the front end that whether the transaction is submitted, it's completed or not. So for that, I have created a loading state here. So let's just implement the loading state whenever someone clicks on the buy ticket button. So it will say loading until the transaction is completed, and when transaction is completed, we can show some alert or some kind of beautified way to communicate that we have successfully bought a ticket. So for that, let's just have a try catch block first. And first we will set our loading variable to true, and then we can await for the buy ticket operation. Once the confirmation is completed, then we can have an alert that you have successfully bought a ticket. So, and in case of error, we can just throw the error. Now, once the ticket is bought, we can set our loading state back to false. And now here, instead of just showing the buy ticket button, what we can do is, if we have loading equal to true, then we can have a loading text, else we can have a buy ticket text. So what this will do is, whenever we click on the button, first the loading state will be set to true, and the text will get changed to loading. And when our transaction is completed, we will first have an alert that the transaction was successful, and then our loading state will turn back to false. So let's try this now. When I click on buy ticket, now you can see this button text has changed to loading first, and my transaction is building. And now if I confirm my transaction, you can see still the status is loading, and now we have an alert that we bought a ticket, and the button is now back to the buy ticket button. So this is a better way to express that we are having a transaction, and it's in confirmation state. Once it's confirmed, then we can communicate the transaction has passed successfully. So now we have got the ticket. We need to show how many tickets are remaining in the contract, in the smart contract which users can buy. So right now I'm just setting it manually to 3. But what we can do here is we can fetch it directly from our storage of the contract. So if we see here, their maximum number of tickets 5 and available ticket counts are 3. So what we can fetch from here is we can fetch the players which have already bought the ticket and the number of available tickets. So we can do it with Taquito as well, but I will show you another way how to fetch the storage of the smart contract in a more efficient way. So we use TZKT to explore the Tezos blockchain. So TZKT also provides some APIs which are pretty powerful in order to fetch the blockchain data. So I have already created an API call for the storage variable. We will use the same call just to fetch the storage from the TZKT APIs. So for that, we will be using Axios. So let's go with Axios, and I think I missed to create the function. So let's just create it. Export const fetch storage. So what we need to do is we just need to do a simple Axios request. So we will do await Axios.get, and here we can pass the API that we just fetched. So we have passed the same contract, and the storage of the contract will be fetched from the postnet API, and we can just return the response from this. So we will do response.data. So in this way, we can just fetch the storage of any contract by just changing the contract address here. Now let's use this fetch storage to fetch the data real time. So here, instead of setting the data directly from the state, what we will do here is we will call our fetch storage function. So const storage will fetch storage. We need to await here as it's an access call. And now we can set the player data. So player data will be the mm, so player data will be the values of this player mapping. So what we need to set here is object dot values of players. So we do storage dot players. So it will set the values from players, and for ticket, what we can do simply storage dot available tickets available. So make sure the name is correct. Tickets available. Now when we refresh our app, we can say the remaining ticket count is 3, and these are the tickets which are already bought by these users. So now let's try buying some more tickets. Let's connect to a different account first. Now when we buy a ticket, the state is loading and the operation is being confirmed. Once the confirmation is done, we will see a pop-up. And now if we refresh the page, the remaining ticket counts is 2, and we have all the 3 ticket holders address as well. So let's buy all the 3 tickets so we can move to the end game button. Let's connect to a third address for the last ticket. So now all the tickets are sold, and here I've implemented another if else condition. So if the ticket counts is greater than 0, then we will see the buy ticket buttons, else we will see an end game button. So as ticket remaining are 0, now the button is turned to end game. And let's call the end game entry point. It will be very similar to the buy ticket operation. So I will just copy paste the same set of code here as well. And instead of buy ticket, we will be calling end game entry point here. And we need not to send any amount to the end game operation. So this will be the end game operation call. It will be very similar to the buy ticket operation call, and we can have the same loading button state here as well. Instead of buy ticket, let's call it end game. And on end game, we just need to call the same set of code again. So we just need to await for end game operation, and we can alert game ended. And on click, we call the end game operation here. So before clicking on the end game operation, let me show you what is the balance of all the count. So when we call the end game function, we will receive 5 tests in one of the three account. So it's 98, 98, and 13. Let's see when the end game operation is done, which address will receive the test. I think the loading state is not implemented. Maybe I missed it. Yeah, I missed it, I guess. So the game is now ended, and let's see the available balance. So it's 103 for the second account. So the second account won the lottery, and if we see on the activity, we received the 5 tests from the contract. So this is how we integrate the front end and connect it from our smart contract using Taquito. So any doubts till now?
We don't have any questions as of now.
Okay, so all the implementation is done. There is few more things which we need to discuss. So once all the transactions are done, there are few scope of improvements which we can do in order to make it more functional and more user friendly. So first thing, we can implement multiple ticket buying function. So user can buy multiple ticket at once, and they do not have to click buy ticket option multiple time in order to get multiple tickets. Another thing we can add is we can record winners from each lottery round. Right now, what we are doing is we are just having a single lottery, and whenever someone wins the lottery, there is no record of the previous winners. So we can store the previous winners in our contract using another big map. Another scope of improvement is allowing buying tickets from FA 1.2 tokens. So user can buy tickets using stable coins like USDT, USDC. So that will be a great scope of improvement as well. And last improvement will be user can have NFTs in, as lottery tickets, so that can be transferable and user can transfer their share of lottery to someone else. So it will be a great addition to the contract and make it more functional. So if you want to continue with this lottery app as your final submission for the TezAsia 3.0, you can continue with some scope of improvements like this, and you can have few edits of your own and your own use cases, and must have a great interface implemented in order to have a scope of winning. So that's all for connecting the smart contract using Taquito. If you have any questions, you can drop it out in the comment section, as well as you can ping us on Discord. We will be there to assist you in the Discord queries as well.
Yes. First of all, please move back to another the previous slide. I have some questions we can discuss and give some ideas to the people who are watching. Actually, my question is
Yeah,
in the last point where you mentioned about give a lottery ticket to the user in the form of an NFT. Would that would be a little bit tricky if like as far as right now with the smart contract, we are only saving about the person who is purchasing the ticket. But if that
mm,
ticket is transferred to someone else, what will happen in
mm,
that case? We actually have to work on this also with the big map, so that if a person transfers the NFT to someone else, we can replace the particular user's address with the person who is sending the NFT, or to whom the NFT is actually sent. Second thing, I think so in the NFT form, oh sorry, the record winning of each lottery ticket you mentioned about it.
mm,
We have to create another map where we will be saving the wallet address as well as the position at which, like, the lottery number, like in which lottery he or she won. So that's another improvement. And what if you can actually create something with FA 1.2 token, where you can purchase this ticket with different tokens on like the different tokens, but in the way that they could be converted to Tez points, and then they can buy it. It could also be a possibility, right?
Yeah, that could also be a possibility. And in the NFT section, instead of just creating another big map, we need to implement the FA2 burn functionality as well. So all the holders of the NFT will be there in the lucky draw when the end game is called, and one of the NFT holder will receive the test prize, and all the previous NFT will be burned.
Yeah,
So in
definitely.
that way, whenever a lottery ends, the all the lottery tickets will be burned.
What if we have another idea that those NFTs we are sending could be dynamic NFTs?
Yeah, those can be dynamic as NFT as well, and once they are burned, we can just update the metadata of the NFTs that they are already used.
So there are endless possibilities with just a simple contract. So
Yeah,
it's like the Greek and the Smart Pi, a deadly combo you can use to build many type of projects, many type of things, and just simple things with so many functionalities. And the more they are actually working, the more is a chance that it could be a pleasant project to be presented during the hackathon. So all the viewers, thank you so much for watching the stream. I hope you got to understood about how to use the Taquito.js for creating a front end, how to actually fetch and make calls to the chain and get the data from it, and fluctuating in between the contract as well as the front end. And in case you have any doubt, you want to ask us anything, or and I probably know that most of the people will be facing some issues when they will be building the front end. I am sharing the Discord link again. You can just drop in, and in the doubt support channel, you can just tag at the rate TezAsia mentor, and we will be happy to help you out with all the support. Okay, so just a second, let me just share about the Discord channel in a minute. And in case someone has any doubt, you can just type it down in the chat section, and we will be looking out on it. Tarun, what are the other resources where you can we can find about Taquito and learn about Taquito?
Yeah, sure. I will share the Taquito documentation here in the private chat. You can share it in the public chat as well. So from there, we can have all the documentation required for the Taquito.
Thank you so
And
much. I will.
there's also a complete code for the current workshop as well in the GitHub. I will share the link for the same, so you can
Yeah,
revisit the code if you missed some part.
that will be actually very beneficial. I think those who are following up with the workshop, they can get an actual benefit, because the template for the wallet connect also is there, so you won't be facing much issues while creating and adding the wallet connect button, because that's the first thing where people actually face errors or some doubts while making the front end. So you can just follow up with this tutorial, and in this boilerplate, you can check out the template and then edit on this and create your own part. In case still you have any doubts, just let us know, that we will be happy to help you. And Tarun, thank you so much once again for sharing your insights about the Gato. I hope that people will be benefiting from this tutorial, and we will be seeing some good things during the project.
Yeah, sure. Thank you so much, Simar. Thank you everyone for attending to this workshop.
And for the updates, this is our fourth session from the TezAsia Hackathon 3.0 workshop series. The previous session was for SmartPy. If in case you are watching here and you don't know how to put the SmartPy, the smart contract in SmartPy, you can just watch our previous session, the third session 3 of how to write smart contracts using SmartPy. And if in case you are in the intermediate series of blockchain development and want to know and understand more about rollups, we will be having a special session on understanding the rollups on Tezos blockchain on 27th of July, 2:30 p.m. IST onward. And we will be actually having Emma Turner from Trilitech, and we will be discussing about rollups on Tezos. And actually, we will be seeing how the Tezos rollups are actually helping out on EVM also, because we can actually deploy EVM code smart contracts on Tezos rollups also. That's right now have been mentioned in the ETHCC or ETHCC, the Paris, and as well as the Thursday, and we will be having special session on this also. So till then, see you all. Thank you so much for joining. Drop in and join the Discord server. And if in case you have any doubt, you can just mention or ask us. And we will be having regular AMA sessions in evening and night. So in case you want to ask us something else, so that you feel we can discuss on the AMA session, just drop in and say hi to us. We will be happy to help you out. Okay. Till then, see you. Tada. Bye bye. Happy hacking.